we are going to move on to our next session, which is idea pitching. This idea pitching, the selection committee that will be evaluating the various pitches. We have Dr. Patrick Rose from ONR Global. We have Scott Wolper from Naval Research Lab. Jonathan Brem. Apologies if I'm pronouncing the names wrongly. Jonathan Brem from the US Army, and Nandini Iyer from the US Air Force. So the order in which we shall be pitching, the first team to pitch will be pitching on synthesis of bioplastics from an automated cyanobacteria and E. coli microbial factory, and the pitch will be made by Stephen Mukuze. After that, we shall have digitizing and discovering knowledge from Maracha Hospital's medical records, done by Dr. Stephen Opio. We shall have design of a biomaterials research laboratory by the Colossal Minds team from Makerere University. We shall have a pitch on the use of protease enzyme from Ideonella sakayensis to biodegrade PET plastic by Erikan Baluku. Shall have enzymatic degradation of GTC waste by Sandra Martini. Shall have Ekin Elim, a phage cosmetic project by Ivy Chimulwa, and water biosensor by Richard Machoka. So in that order. Once again, the rules are 5 minutes strictly, at 3 minutes. The gentleman, Victor, wave to the people. I think you'll be seeing him from here. So he'll show you 2 minutes left, and after 5 minutes, the technical team will turn off the microphone. Okay, great. So let's listen to the first pitch, and that is synthesis of bioplastics from an automated cyanobacteria and E. coli microbial factory. So I'm going to sit where Victor is. When I signal you, you start. Okay. Okay, Mr. Stephen, are you ready?
Yes.
Start.
Right, hello everyone. My name is Stephen Mukuze, and I'm the CEO of a startup called Umkele Inc, and we're developing biodegradable plastics for packaging. So on the team, we have a diverse team that has the requisite competent skills to develop the project that we're about to propose, and we also have a research paper on the topic. We have several mentors from Camelot Innovation Labs, Petra Data Science and Material Innovation Initiative that are helping us with the technical aspects of the project. And we also have business mentors from Green Tech Festival and Salesforce. Right, so the problem that we have is that we have bioplastic pollution in the world. And only 10% of bioplastics are actually recycled. The rest end up in landfills. And these landfills are a biological and a hazard and a health hazard. So our solution is we've designed a microbial system that uses sunlight and carbon dioxide as the sources of energy to develop glucose that will then feed the E. coli system that will develop the biodegradable PHA plastics. So these plastics will completely degrade in the environment in 3 to 5 months. So this system that we've developed is modular. So apart from bioplastics, we can actually develop other materials in the health field, pharmaceutical field, and other biomaterials. But for our prototype, we will begin first with biodegradable plastics. So our energy is significantly more environmentally friendly, especially when you're comparing it with other like traditional industrial practices. Also, because we're using sunlight and carbon dioxide as the sole sources of energy, we've negated the use of agricultural sourced feedstocks, which account for 50% of production costs traditionally in this field. So there are actually no commercial bioplastic producers in Africa. So we intend to be the sole producers of bioplastics, which will give us a competitive edge as Africa is the cheapest production location in the world. So at the moment, the global bioplastic market is valued at $21 billion. It's expected to grow to $324 billion by 2030. So our strategy is we're going to be selling PHA bioplastic resins to traditional plastic manufacturers, and these manufacturers are the ones who make the final product for consumers. So we intend to build a 1 million ton per year plant, and we'll be selling our bioplastic resins at $1.20 per kg, which will mean we'll have a yearly revenue of 1.2 billion. We intend to expand this to a 10 million ton plant, which will increase our yearly revenue to $12 billion. So we have several competitors in our space, but most of the competitors that are using microbes in their processes, they use like agriculturally sourced stocks, as I said, which account for 50% of production costs. So the result is that their actual product is very expensive, and there is low market adaptation for their products. And then the other competitors produce like petroleum-based plastics, which are actually not sustainable at all. So for our protection strategy, we have a provisional patent for our process. Our company is legally registered in the Seychelles, and all our contributors and collaborators have signed NDAs. We have won several awards, including the IGEM EPIC Biohackathon award. We won first place. We also won first place in the IGEM EPIC VCL competition, and we won first place in the Green Tech Festival. All these competitions were held this year. So for our milestones, we have developed mathematical models for the process. We're in the middle of developing computational models. So next year we intend to begin the wet lab. We will publish our results in 2023. And then by 2025, we intend to build the pilot plant and start commercial production. So we need a total of $400,703 to be able to develop our prototype, and most of this amount goes to the lab work. So we thank you for your time, and we hope that you help us create a greener future for Africa and the world. Thank you.